This startup founder is building the first data center in space.
The first is we're doing like edge and cloud compute for other satellites. So we're having these like small compute nodes that provide compute to other spacecraft, basically.
This is Philip Johnston. He's the founder and CEO of a space startup called Starcloud, a Y Combinator-backed startup that's trying to build a fully fledged data center in space. What makes like that advantageous versus just plopping a data center in Dallas, Texas, and just saying, hey, we're going to use a ton of water to like run and cool this thing?
Yeah, so in space, the ambient temperature is 3 degrees Kelvin, which is about minus 270 degrees C. So it's like extremely cold.
Philip recently joined us on the Vesting Show to discuss his plans to make data centers the restaurant at the end of the universe and the challenges that come when undertaking such a difficult mission. I'm your host, Bryson, and this is Vesting. I want to jump in because before you were building these crazy data centers in space and meeting the Prime Minister, I want to jump back and just learn more about Philip as a person, as a human, your background. If you could give everyone listening the who is Philip Johnston, what would it be?
Yeah, my background, well, if you to go right the way back, I'm from the UK. I'm the youngest of 5 boys. I've got an identical twin brother. I lived in South Africa immediately after being born. We moved out there for like 6 years. And then my dad was a diplomat, so we were out there with the British government. And then moved back, was in the UK for ages, and then left to go to grad school in the US, studied math and physics. And then I did like algo trading for 5 years with the bank. And then went back to then I did VC back in South Africa for a year. And then, I've been all over.
Was there anything in your like childhood that made you gravitate towards space? Like, were you like always an enthusiast of what exists beyond the frontier?
Yeah, definitely. I mean, like when I was a kid, I wanted to be an astronaut and like all the things like, I was big in space. I wanted to do nuclear fusion. I wanted to like do research on nuclear fusion because I was math and physics were the only things I was good at. So I was like, maybe I'll become a physicist or a mathematician or something. And nuclear fusion seemed like the cool thing to do.
Yeah.
What I like about what we're doing now is it's like potentially much more impactful in that we could generate way more energy than you can generate doing nuclear fusion, doing what we're doing now. So I think that's kind of cool.
You said growing up, you spent time in South Africa. You kind of like traveled a bit. Like you were kind of moving around a bit and trying different things. And it seems like that may have yielded also you being willing to move around and try different things into your professional career. Was there ever a moment pre-Starcloud where you were like, okay, this thing's cool, and I kind of just want to go in that direction or learn more about like space or data centers? You said you had this nuclear foray. I'm just wondering, what in your early adult career kind of gravitated you towards thinking this whole space thing was possible?
That was probably, during my time at McKinsey is where I started to see that the launch cost was coming down. And then, to be honest, I just used to consume a lot of YouTube content about the Starship program that SpaceX is building.
Yeah.
And there was a YouTuber called Tim Dodd. His name on YouTube is The Everyday Astronaut. Mm-hmm. And he made this video about going down to Starbase, Texas, and he showed you around. He was like, look, you don't need a tour, you can just come, you can just drive around, like here are the roads, this is where you stay, this is where you can get a drink and whatever. So I was like, shit, I could just go and visit Starbase, Texas. So in like 3 years ago, I just got a flight on a weekend, like not for work, just like for fun.
Just pulled up.
I just literally put up on my own in Starbase, Texas, and I just like was looking around, and like it was before even the first Starship launch. Like nobody was really talking about Starship except for like the YouTube nerd community. And like that, from that moment onwards, I was like, holy shit, what they're building here is going to change everything. So that's when I was like, okay, look, like I need to get involved in this somehow. And we started with my co-founder looking at different ideas. Like one of them was space-based solar, which is where you have huge solar panels in space and you somehow beam that power down. We're on Starcloud now. And another is, the problem with that is you lose most of the energy transmitting it from space to Earth.
Yeah.
So then we started thinking, okay, well, like if you had a cheap way to get whatever you're going to consume the power with to space, that would mean you wouldn't lose all of that. And I mean, you wouldn't need to send so much solar panels into space. So like the most obvious thing then is data centers, because almost all new energy projects on Earth are being built for data centers. So that's when that became the basis of a white paper that I put together with my co-founders, Ezra and Adi. And and then that became the basis of the company, basically.
When you look at kind of the undertaking of taking an idea that's very pie in the sky, data centers in space, the whole idea, I'm guessing, is like, hey, you can get rid of the heat, you can get rid of things a lot easier, and you can run them more efficiently because, you know, in space, you don't have to deal with some of the elements that you would be dealing with here on Earth. Did you always have the belief that you could turn this into a company immediately, or were you kind of just figuring out how far this thing could go?
The first is we're doing like edge and cloud compute for other satellites. So we're having these like small compute nodes that provide compute to other spacecraft, basically. So yeah, that's like a business that we can do with the current launch cost that will be profitable. It enables us to develop and build the technology as we go, though. If the launch cost were to never come down, that would be a pretty good business just in itself. Nowhere near as big as competing with all data centers on energy cost.
When you think about kind of the stepping stone of, you know, the long-term business model, and I guess the way to break it down would be when a company is smaller, maybe they have an idea of like what a business model would be to get them to stage 2 or stage 3. But for you guys, I mean, the goal is eventually like, how do we just service companies that need to run their data in space, whether it's, you know, big loads, training LLMs, which we're gonna get to. But how have you guys gone about designing business strategies and pricing models for, to your point, like earlier stage products that you can provide that eventually yield the results needed to get you into space consistently?
As I say, as you mentioned, in the end state, yeah, well, we're planning on serving everybody that needs kind of compute in space. We'll be serving. In the short term, we're basically targeting the highest value workloads. So that's, to be frank, mostly like Defense Department, as well as like anybody that's willing to pay more to do their compute in space. So like Earth observation satellites are willing to do that. There's some crypto people that are super keen to do stuff in space for some reason.
I don't know what you, I don't know, maybe you're mining Bitcoin in space. I'm not sure.
We will be. No, we literally will be on the second satellite. We're going to be mining some Bitcoin in space.
Is mining Bitcoin in space or having an H100 train an LLM in space, do you see these as like just landmark marketing moments that show off the capabilities of like where you guys are going?
So like, for example, training Nano GPT from Andre Carpathy. If you go to the Starcloud 1 tab, you'll see a couple of nice videos and things. Yeah, click this sound button on the bottom left.
It'll play.
Starcloud 1 separation confirmed.
Oh, it's so beautiful.
Starcloud 1 separation confirmed.
So walk me through this, right? Like how big is this payload actually? Like when you guys were like, okay, we're gonna send this into space. How big is this payload, and like how much does it actually cost to catch a ride on a SpaceX rocket?
It's honestly like pretty cheap. It's the size of a small fridge. So it's like this big.
Oh, okay.
It costs, the launch cost was like $400,000, which is like dirt cheap. Like compared to what it used to be, which would have been like $5 million per launch.
Jesus.
Yeah, because of SpaceX, because of the rideshare program. Like literally the next rocket up would have been like $5 million. So SpaceX is about 10 times cheaper than anybody else. And then the satellite bus was about $1 million, and then everything else we did inside that was about $1 million. So you're talking about like $2.5 million to launch that thing. We raised like a $2.4 million pre-seed at 10 post.
What?
Because it took us 3 months to get that together. Nobody wanted to give us any money. That was before we got into YC. We got rejected from YC twice. So sometimes people think we have an easy time fundraising, which we do now, but we didn't always.
Yeah.
I know what it feels like to bash your head against the walls trying to fundraise. But like I used to tell our investors, hey, we're going to do this whole spacecraft for $2.5 million, and they're like, nah, I think they thought they would fund the pre-seed and then we'd have to raise again to get this up. But no, we did it for $2.5 million. And one of the reasons is my co-founders basically built the entire payload from scratch, like not the bus, but like all of the compute module and tech. So like Ezra and Addy basically built this whole thing from scratch, like soldering shit with their hands and like, yeah.
How big is your team, and how much of that first payload going out, like how much of that was like very like high risk, right? Where you had to decide there are certain components and things that might not work in space? Like, were you 100% certain that this would work, or were you kind of taking a risk as well?
No, it was a big risk, to be honest, because if you'd contracted Lockheed to build this H100 in space satellite, it would have been $50 to $100 million to get them to do that. So
That's insane.
Yeah, it was a big risk.
You said you were fundraising for Starcloud before YC, and it was like it was the hardest process ever. When you think of kind of that duality now, where it's like people probably want to throw money at you, they see the Elon post, and we're going to get into that stuff in a bit. But for what you guys have done with the money that you originally raised, you were able to take that very far. What was some of the common rejection excuses you would get from VCs in the earlier days when you were saying, hey, we need to go put data centers in space, and this 2 million is going to be the start to that?
I mean, to be fair to the VCs, we weren't really pitching this longer term vision at the beginning. We were only pitching like small compute nodes for providing inference for other satellites. So like lots of people said it wasn't a big enough market.
The lift around putting an H100 in space. When you guys came up with the idea to do this, what was kind of the thought process behind resource intensive, the timing it would take to get it done? How long did it take you to actually bring this to life from like 0 to 100?
We put the spacecraft, we founded the company January 2024, and it launched in November last year. So it's 22 months 21 months from founding the company to launch. That is a huge record. The fastest I've ever heard any company going from founding to launch is 4 years. We did it in 21 months.
Kind of stick with this training LLMs in space topic. How much of this do you believe is kind of like a necessary step to the overall end goal of databases in space? Like, do you think there's a world where at first we're just offloading small payloads like this as training as a service models in space?
As soon as the launch cost gets to about $500 a kilo, then almost all inference workloads will go to space. Actually, we're not going to be training anything for a very long time. Like at least 10 years, there won't be training in space. The reason we did training is to show training is a workload where you need to run the thing continuously for quite a long time. And that means there's a lot of heat coming off it. So for people that, are in the industry, they look at training and they go, fuck, if you can do training, you can do anything, because we know that this chip's been kicking out heat for quite a long time. But we won't actually be training a model for ages. And the reason is, to train a frontier model, you need probably a 500 megawatt data center. In 5 years' time, but when Starship is at volume, you'll need probably a gigawatt data center. And there's no way in 5 years' time we can launch a 1 gigawatt cluster, because it means you've got to dock the whole thing together. Because for training, the whole thing needs to be internally networked. You can't do it with like a laser connection. For now, it's just inference. We're just going to do inference for now, forever, basically. As soon as Starship is ready, like we can launch shitloads of those. In the meantime, we will be launching these small, compute nodes that do inference for other satellites.
When it comes to heat emissions, right? Because that's like one of the main like reasons why in space data centers, training in space could be interesting. Like, could you break that down for me? Like, what makes like that advantageous versus just plopping a data center in Dallas, Texas, and just saying, hey, we're going to use a ton of water to like run and cool this thing?
Yeah. So in space, the ambient temperature is 3 degrees Kelvin, which is about minus 270 degrees C. So it's like extremely cold. The problem is, there's a few different problems, but one is that it's a vacuum. And so getting rid of that heat, you can't do it just by like blowing air past it, or convection or conduction, or however you would do it on Earth. The second is the sun produces obviously like a lot of heat, so you need to shade from that. But so the way that we get rid of heat is, instead of using blowing air past it or water or anything, we run coolant past the chips and then out to a very large deployable radiator. That radiator just has large surface area that glows in infrared, essentially, out into the vacuum of space. That means we don't need to use any water. It's not like mega easy. That's probably the biggest engineering challenge, is building this radiator. And that's what, probably 70% of our engineering team is working on, building this radiator. But it's a good moat, it's a defensible moat once we've got it.
Yeah, I was going to ask, is that like, from a technical standpoint, something that, whether it's you, competitors, anybody else who's trying to do something similar, you're all still trying to figure out what does the ideal radiator for this issue look like in terms of solving it, and then being able to put it out there and be in a space where you don't have to go up and deploy it 24/7. Because I'm thinking, like, if there are issues when it comes to repairing something like this, and maybe it gets cheaper when you have consistent rockets going up and down, but would this be something you see as like self-fixing, or would you have to get a technician up there and say, hey, you're living on this space database for 3-6 months to make sure nothing breaks?
It certainly wouldn't be a human technician. It might be a robotic technician in maybe 5 years, like a sort of Optimus type technician, which would be like obviously way cheaper than doing anything with humans. So yeah, no, for now, we're not going to have access to the spacecraft.
You chatted with Paul Graham, and then Elon chimed in later on once he saw you were talking about space data centers. But you recently, I'm guessing you were in SF and you guys connected and just chatted about the work you've been doing as like space data centers have been on the trending.
He is like the most high energy person I think I've ever met. Like, I was like talking to him about what we're doing, and he was like bouncing off the seat. He was like, holy, so I was like telling him like, yeah, we're going to do a raise and it's going to be this much. And he goes, so you're building a $20 trillion company and you're selling it for how much? That is the biggest bargain I've ever heard. That is such a bargain. And then he goes, he like immediately, invested and whatever. So yeah, it was he's just like an absolute character, and he's so positive, and he's such a high energy, and he's such a good laugh. So yeah, it was great.
Was there any good advice that he gave you going into, what presumably in the very near future would be a fundraise, but was there any cool advice that he gave you during you guys' chat?
It's like running a sprint where if you're running a sprint, unless you're like Usain Bolt, you're not looking to the left or the right. You are just in your lane and you're going. You don't focus on anything else besides going as fast as you can. And he's like, same as Starch. You just go. Like what you're building is potentially the most valuable thing in the history of humanity. Lots of things can happen between now and then. Just do the best you can. Like, there's a possibility you get crushed. There's a possibility you don't.
I'm not gonna lie, that's badass advice. That's like such badass advice. It's like, listen, I'm gonna invest in you, and who knows, it could not work, but there's a chance it could fucking work, and there's a chance that you don't get crushed. So I want to take you to a question that I have, because especially on the internet, there's tons of conversations about like space and space junk and like what's actually out there and all these different things. When you think of what you're trying to build in space, kind of, we're entering almost this like quasi Cold War of everyone's trying to get back into space, and the moon and all these things are now like really cool again. When you think about that, what do you think people are getting wrong, or like some major misconceptions about space data centers, the importance of the frontier and dominating it? Tons of propaganda out there, but what do you think people are getting wrong?
I don't think people should be as worried about like near peer adversaries as they say in the military, which means China. Because as they are, like, lots of people think, oh, it's like a space race to China. The US is going to have like 99% of all launch capacity within 3 or 4 years because of Starship, and the Chinese are nowhere near. Like, they are nowhere near. So I think the US is going to win the next space race because they're going to have like literally 100 times more launch capacity than everybody else. So that's probably one thing on that front. In terms of like the fear of space junk and things like this, we need to be like very vigilant and very proactive about space junk and all the rest of it. But it's not as big a problem as people sometimes think. And the reason, so sometimes people think there's this imminent possibility of this Kessler syndrome effect, which is basically if you had one collision in space, it would create like millions of fragments, and then they would hit other satellites, and they would hit all the other satellites and whatever. That's actually basically impossible to happen right now because of where the satellites, almost all of them are flying at like 450 kilometers altitude. And all of the Starlink satellites have just lowered their altitude to 450. Anything that happens that is a collision at that altitude will deorbit within like 3 months.
Do you think people have like kind of a same irrational fear when it comes to like, oh my God, there's a random asteroid out that scientists are predicting could come within 100,000 meters or whatever the thing is of the Earth's atmosphere? Like, I've seen tons of those where it's like, those like meme
Yeah,
or
1%
factual.
chance yeah.
Yeah, do you think like that's like that stuff is, even if there was something, right? We probably would create a weapon that could just destroy it to shreds, or I don't know. I'm just thinking out loud.
Certainly in like 50 years we will be able to. If there was to be an asteroid coming towards Earth right now, asteroids are like pretty hard to see, so you don't get too much warning. Like we would probably have a few weeks warning, but like not necessarily much more than that. So depending how big it is, obviously, and especially if it's like an interstellar asteroid, we would be toast. But there's not too many of those. So
Oh shit. You took the company, you guys end up getting into Y Combinator. What was the process like of pitching something that was like very pie in the sky? Like you didn't, it's not like you have traction, it's like you have something that's like, oh, this is tangible, really. But what was the process of like pitching to get into YC?
yeah, well, we pitched twice and we got rejected the first time. We got in the second time. We were mainly for the first time we were pitching providing cloud and edge compute for other satellites. The second time we pitched, at the very end of the interview, I remember it was Nicola. I can't remember his last name, but anyway, he was like, in one of the questions. No, actually, in the demo video, at the very end, Ezra had said, "We see a path to moving all compute space," and Nico goes, "We'd done this like quite brutal 15 minute interview," and at the end, Nico goes like, "I didn't really understand that point in the video about like moving all compute space. Can you just touch on that for a sec?" And I go, "Okay, this is a question for Addy." So I turned it to Addy, my co-founder, because he's like, he was at SpaceX. He's like, and Addy just like riffed for like a few minutes about like, actually all computers can be in space. It's the only place you can do it. Like, it doesn't make sense to do compute anywhere else, whatever. I think honestly, that probably actually had helped us get in. So yeah, like they love big visions. Actually, do you know what? With YC, they don't give a shit about the idea. They only care about the technical talent on the founding team. Like that, as far as I can tell, that's the only thing. That and also traction divided by time. But if you have great traction and bad technical co-founders, you won't get in. If you have bad traction, great technical co-founders, you still can get in.
So at the end of the day, it's like a lot of teams, you shouldn't even be focused on really the idea or anything. You should just focus on like, how can I go? Like if you're non-technical, but you're great at selling, right? Like your main focus should be, how can I go find the next 100x person that will give me the best chance of having an absolute superpower on my team, and then using them as like a, hey, I do this thing really well. This guy is best in class in his industry at X, Y, and Z. We want to build a company, and then you can figure out the idea because you're going to pivot from there.
Exactly, 100%. In fact, YC is not shy about this. YC put out this great video that I sent to basically all of my non-technical founding friends called "How to Found a Tech Company with No Technical Skills," and the whole thing is basically about how to recruit a tech co-founder. And it's like, it's just beautiful. I love this video.
What would be your biggest advice for someone who is non-technical and needs to recruit somebody technical on their team to really succeed?
So like, your value proposition as the non-technical person is like bringing cash. Like that's your main value proposition, cash in the form of fundraising and customers, which your co-founders do not want to do. And if they're like kick-ass engineers, they don't really love fundraising usually, or so like they can do it. And to be frank, you are much less valuable and much more replaceable than they are. And I hold my hands up. I'm like more replaceable and less valuable.
Stop it!
No,
you're the best CEO ever.
So just go into it with that mindset. Like, if you're gonna, your value prop is bringing the fucking cash, and like bring the money. Bring the fucking money, as whatever his name is, like Bob Geldof said. So go into that mindset, like prove that you can bring the money, and then your co-founders, they might be interested.